Growing up, I used to play a lot of Club Penguin, and Card-Jitsu was probably my favorite minigame. The rules were very simple. Each player had 5 cards, fire, water, or ice, with a number on them. Each player would pick a card and compare. Fire beats ice, ice beats water, and water beats fire. If they matched, the players would compare the numbers on the cards, and if these matched, the round would end in a tie. Otherwise, whichever player won the round would take the card into their win pile. And to win the game, you had to collect either 3 of the same element or 1 of each type of element. In this video, we'll be looking at how Club Penguin communicated over the network, and how we could listen in to create a cheat for Card-Jitsu, which would let us know the other player's cards before they were played. The original Club Penguin was shut down by Disney on March 30th, 2017. However, many fan-made recreations have existed since then, including Club Penguin Rewritten, Club Penguin Online, New Club Penguin, and Cpps.io. In this video, we'll be playing on the last one because, as I will show you shortly, it does not encrypt its network traffic, which makes it a very easy target for this example. Okay, so let me show you what this traffic looks like. I'm going to log into Cpps.io on my computer and on my laptop on 2 different accounts. We'll play a game against myself, or I'll play a game against myself. We'll look at the traffic and we'll see what exactly is going on in the background, right? So let me log in on both computers. Cpps. Here and here. This one is BMDYY. And on my laptop I have not BMDYY. And we're both going to be on screen in a second. Okay, here we are. So, let's head over to the dojo so we can play some Card-Jitsu. We're both here. Okay. Alright, so we're both in the dojo. The first thing we want to do is figure out who is Club Penguin communicating to, like what IP is the server. So, we can use sysinternal suite. I have one here. TCP view 64.exe. And we can look up cpps.io.exe and we see there are 5 connections. 4 are TCP v6, 1 is TCP to this IP. We want to start up Wireshark and look at packets coming from this IP, because we know that they're coming to the cpps.io.exe process. Okay, so we can do ethernet ip.source equals 146.59.154.2. Okay, we're filtering for packets from the IP that is connected to cpps.io. And let me make this window a bit smaller so we can see everything at the same time. That should be good. Alright. So, let's get into a game. We're gonna sit on this practice mat. And we can already see a bit of traffic going on. You're gonna notice all these % symbols and a bunch of packets in plain text. So we have a deal packet here. I'm gonna pick a card. We have a pick packet. I'll pick a card on my laptop. We have 2 more packets, a pick and a judge. And very quickly it's easy to realize that these are the actions that are being carried out. So each time I pick a card, a packet's being sent, and presumably the information about the card that I picked is within this packet, right? The point is, we figured out that this is the IP that CPPS receives its information from, and we should be able to read from these packets some information that we can use. The Club Penguin protocol is made up of a lot of events, and luckily we only need to worry about 6 of them, which are relevant to Card-Jitsu matches. First up, we have the game start event, which starts with %xt, %uz. So, here we go. This is the game start event. It contains information about the 2 players, including the side, the name, the color, and rank. For the side, a 0 indicates that the player is on the left side, and a 1 indicates the player is on the right side. For the rank, it goes from 1 to 9 for the 9 different belt colors, and then 10 is if you're a ninja. Okay, so next up is the game over event, which is identified by starting with %xt, %cjsi. Let me find it real quick. This packet is sent exactly once when the game finishes. I have no idea what these numbers mean, but it wasn't required to figure out what they mean for the cheat to work, so I don't really care what they mean. The next event is the deal event, which is sent each time that a card is dealt out to a player. These last 4 events are all going to start with %xt, %zm, but there will be a specific action written out as the 4th token. So let me show you real quick. XTZM. Okay, here you go. So deal, right? XTZM 113 deal. Deal is the action. XTZM, there are 4 events which start like this. These packets contain a card object and the player side it is being dealt to. Card objects contain the number, the ID, element, value, and color, and a flag if it's special or not. One thing which is important to note for later is the difference between card number and card ID. The server assigns all dealt cards a unique number in sequential order, so the first 10 cards which are dealt out at the beginning of a game are assigned numbers 1 through 10. Subsequent cards are 11, 12, 13, etc. This number is important because this is what the next event will refer to. Next, there is the pick event, which again starts with %xt, %zm. Let me just find one real... Okay, there it goes. So the pick event is sent each time that a player picks a card to be played, and it contains the player's side, so the right side in this case, and the card number. Not the ID, the card number. So in this case, the player on the right side played card number 7. After the pick event, we have the judge event. So both players pick a card, 2 pick events are sent, and then a judge event is sent, specifying which side won the round. The last event that we have to cover is the power event, which is sent whenever a card which wins the round was special. You can identify these cards with a power aurora around them, and the numbers in this event, I'm not really sure what they mean, but it likely indicates which special powers are currently in effect in the game. And that is it. All the events which are sent throughout the card game are one of these 6 which I just explained. Since all these events are sent to us unencrypted, as you just saw, it's very easy to cheat. So easy that you could, for example, read the network traffic during a game and make it work. So, for example, if we played a quick game... Yes. Filtering for the correct packets. We can see the cards which were dealt out, and we know that our enemy is on side 1, and so he picks a card. We can see he picked card number 8. We look in here and we see, let's see, 1, 2, 3, 4, 5. Card number 8 is Snow 2, so we play a fire, and there you go. We figured out which card he played, right? He'll pick another card, I'm not looking, and let's see, he picks card number 9. So we look back in here. 6, 7, 8, 9 was the 6 fire. Pick a water. And there you go, 6 of fire. It's that simple, really. Although we've already technically achieved the goal of being able to cheat in Card-Jitsu, racing against the clock to read packets out of Wireshark is pretty uncomfortable, to be honest. So you could write a Python script which does it automatically for you. Or that's what I did, at least. Let's take a look. So I used the ScapeI library to access these packets, and I used Colorama to make everything look nice. I created 3 objects. So I have the card to represent the card objects that are sent through in the deal packets. So number, ID, element, value, color is special. I have a hand class, which is just it represents the 5 cards that each player has. And I have a player class, which is side, name, color, rank, and hand, the 4 of which are given in the game start event. The hand is the hand class that I defined just above. So we have 2 global variables to store these player states, and at the bottom we use ScapeI's sniff function to start listening on TCP and pass these packets that we sniff into the process packet function. This is the process packet function. This is the majority of the code. This is where we're really sniffing through everything and looking for exactly the information that we need. So the first thing we're looking for is the packet coming from this IP, which is the server that we identified? Is the packet in IPv4? So not IP6, it's IPv4 specifically, and does the packet have a raw data section? If it doesn't have all of this, we can skip the packet because it's not one that we're interested in. If it does have all of this, let's continue. We extract the raw data from the packet, which is the % separated string, and we start checking the beginning. So if it starts with xtzm, xtuz, or xtcjsi, it's a packet we care about. If it's not, it's some other Club Penguin event. It doesn't matter to us, we can ignore it. We can go ahead and split the packet up by these %, and then we get into actually handling the specific events. So on game start events, which are sent once, we reset the player objects and initialize them with the information given to us in the game start event. So the player name, side, color, and rank, right? And we print out game is starting. On game over events, we print out game over. There isn't much to do. And on deal events, so every time we get a packet of a card being dealt out to a player, we're going to go ahead and update the hand object in the specific player. So we'll add the card for whichever player the card is given to, and we'll print out his hand. So this will make sure that we always keep track of what cards both players have. Remember, this is very important because the pick events refer to the card number and not the card ID. So unless you keep track of all the cards and the order in which they were dealt, then you won't know which cards are being picked. This is where we handle the pick events. We check the number of the card from the pick event, we check which player picked the card, and we write out this player picked this card. And we remove the card by the number from that player's hand. So he played the card, it's not in his hand anymore. We have the judge event, which is saying which player won the round. Power events I ignore in this program. You could probably figure out what exactly the powers mean. The powers do affect which card wins. So for example, there's a power that if two cards have the same element, instead of the higher number winning, the lower number wins. I wasn't able to figure out how to understand the numbers in the power event, so I just ignore it in this script. And it works. So let me give you a quick example. Cheat-Jitsu is running, and let's go. So, game is starting. BMDYY is player 0, left side, BMDYY, or not, BMDYY is player 1, or the right side. Left side's hand looks like this. Water 10, fire 6, snow 3, snow 10, and snow 7. Player 1 hand looks like this. Player 1 picks Snow 10 special card. We'll pick a fire. There you go. Player 0 picked Fire 6. Player 0 won the round. It's not doing anything fancy. It's doing what I did manually just a couple of minutes ago, reading out the packets as they're coming, right? So it's a lot easier, obviously, to read it out of here instead of through Wireshark. So player 1 picks a water. We'll pick an ice. There you go. And let's do one more round real quick. So, player 1 picked fire 6. Oh, perfect. We'll pick a water and game over. We won the game. There you go. Just an example of what you can do reading the traffic from and to Club Penguin servers. Cheating in Card-Jitsu is pretty boring, to be honest. I don't recommend doing it. In fact, I ask you not to cheat in this game, please. It just ruins the fun for people, and this is a children's game after all. This is just for educational purposes anyways. In any case, that's it for this video. I hope you enjoyed and/or learned something new. Next week we'll be looking at a different server, a more popular one which uses encrypted communication, and we'll see how that can be overcome. It's a bit more interesting, it's not straight up reading out of Wireshark. Until then, I'll see you in the next one.